Blast from the past for me. Joining me on our VIP line, Dr. Jonathan Eisen. So John and his brother Mike and I, we grew up in Bethesda, Maryland together, and we would be running around the neighborhood or riding bikes around the neighborhood or playing football on different people's lawns around the neighborhood. And then, you know, we all did our own things. And John, when's the last time you and I actually heard each other's voices?
Maybe 5 or 6 years ago when I was possibly coming out to Colorado, but I don't think I've talked to you since high school.
Yeah, I think that's right.
Amazing.
Since probably the late 1980s or something was the last time I've actually heard your voice.
Yeah, before email even existed.
That's right. You've been busy since then. According to this internet thing, which I actually think may be around to stay, this whole internet fad. I'm just trying to catch up with it. But it's calling you professor.
Yeah, it is. I'm sorry about that, but yeah.
So John is a professor of many things in several departments, including one that we're going to focus on today, the Department of Medical Microbiology and Immunology at the School of Medicine, Coastal and Marine, and the Coastal and Marine Sciences Institute as well at UC Davis. By the way, how's California treating you?
Yeah, California's pretty good. I mean, we had a rough patch with the fires and the smoke recently. We had to shut campus for a week, and my kids' schools also shut down. But mostly California's pretty good. It's beautiful out here. I'm a late night person, but today I got up early for this, so I got to see the sunrise, which is weird for me.
That's funny. I rarely see the sunrise either because I'm up before it and I'm in my studio.
I actually took a picture for you of the moon, which I almost never see.
Oh, that's pretty funny. All right, so let's talk about some of this fascinating work you're doing right now, because I think if we do a whole show of reminiscing, my listeners will get bored. But one of the things that you work on is microbes on space vehicles, including the space station. And you told me you now have a grant to study microbes that can survive not just there, but in NASA clean rooms, which by definition are supposed to be clean. So what do we need to know?
Yeah, I mean, what we're interested in is basically, microbes are everywhere, of course, everywhere on Earth, and they also are, on space vehicles like the space station and the rover and other things that get sent out to space. And so we're interested in general in how those affect either the science that people are trying to do with those vehicles or also the health of the humans, plants, and animals that are inside those vehicles like the space station.
You may recall that, and we actually had a little fun with it on the show, just over a year ago, NASA put out a job posting for a planetary protection officer. And we were kind of goofing around with it and, science fiction movie kind of stuff. But, I mean, that's kind of what you're doing in a way, right?
Officer.
You know him or her?
Well, I think it's a her now, but I met John Rummel when he was the planetary protection officer at a scientific conference, and that's actually how I got interested in this topic. So I used to work on organisms that could survive incredibly extreme conditions like lots of radiation or boiling temperatures or freezing temperatures. And I was studying that from an Earth perspective, but it turns out NASA is really interested in those organisms both because they might sort of survive in outer space if a piece of Earth gets, knocked off, but also because of this clean room issue where they're trying to, produce a space vehicle that has no life on it because they're sending it out to some planet to study whether or not life exists there. And they'd like to have that be completely clean, and so one of the things they do is they try to sterilize those facilities. And the methods they used to sterilize them were also the methods that I was interested in, how organisms were resistant to them.
So I can imagine a few issues here. So one, you've mentioned a couple of them. One, bringing Earth bacteria to other planets, and then another is the health of humans that are traveling to other places or on the space station. Yeah, let me ask you about a couple other. Is there any risk of, and this may sound science fiction-y, but I mean it as a serious question. Is there any risk of a microbe going into space and acquiring, because it's in space, some kind of mutation that could cause a larger issue if it gets brought back to Earth?
Yeah, so actually NASA studies that quite a bit. I mean, I don't think that that's a large risk because on Earth there are hundreds of trillions of microbes that are always getting exposed to radiation and other mutagens, and they see all sorts of different genetic changes. And just sending a few up into space, the probability is not really going to be high that those would see something that they wouldn't see on Earth. So I'm not that worried about it, but a lot of NASA is thinking about if you have microbes that show up on like the space station or some, if astronauts are going to go to Mars, for a long period of time when they're sitting out there, you know, getting exposed to space radiation or something like that, they will accumulate mutations. I don't think it's going to be that different from what happens on Earth, but they will change, and, you know, selection of organisms out there, if you get something nasty, it's very hard to fight.
My producer, Shannon, has a almost dangerous obsession with something called a water bear. Do you know anything about these things?
I do. I actually have colleagues that work on them, and I was interested in sort of the equivalent in the bacterial world. There's a bacteria that you can irradiate until your test tube basically starts to break and it doesn't care. So it's kind of like the bacterial equivalent to the water bear.
So tell us, just because only Shannon and you know what a water bear is among all the people who are hearing this conversation. So can you tell us what it is and why it's interesting?
Well, so there's, you know, over hundreds of years of research, people have tried to find organisms that can survive all sorts of extreme conditions. And there's this really bizarre group of organisms called, you know, formerly called tardigrades, although, you know, they're generally known as water bears and other things, that they're tiny, tiny little animals, basically, sort of almost microscopic. You can see them occasionally if you have a really big one without a microscope, but I think basically everybody looks at them with microscopes. But they're actually animals, and they survive incredibly extreme conditions like desiccation and radiation and other, you know, various stresses. And so, you know, a lot of biologists have been interested in what the hell are they doing? How can they do this?
So how can they do it? Do we know?
Yeah, I mean, I think, you know, I don't study them, so I'm probably not the best person. I can tell you all about the bacterial world,
all right.
Not as much about the tardigrades. But I mean, basically, what people have been looking at is, you know, taking them, rearing them in the lab, and exposing them to various stresses. The one I know most about is radiation, and you can basically, you know, pump tardigrades with gamma radiation thousands of times more than like human cells would survive, and they're like waving at you saying, "Hey, how's it going?" And you know, the mechanisms by which organisms can survive that, there are basically three ways that they deal with that. They can either protect themselves from the damage. That's really hard to do with certain types of radiation, but it is possible. So gamma radiation, in addition to like breaking up DNA, it also causes damage to like cell membranes and proteins, and these organisms have ways to protect from some of that damage, but they still get lots of damage. And what they do is they repair it. So they have, you know, fancy mechanisms for repairing damage at higher rates than other organisms. And that's why these organisms are of great interest, because if we can figure out how they're doing it, maybe we can transfer those processes to other organisms that, you know, we care about more. I mean, tardigrades are awesome, but we're trying to figure out how to, like, get humans to survive radiation exposure, or how to get various plants and animals to better survive.
Right, and that's what occurred to me when you were describing the process, is that if they are surviving high-dose radiation by self-repair, that repair has to proceed at a very fast pace, otherwise they'd die before they got enough repair done, right?
Yeah, so a lot of them also shut down sort of their metabolism better than other organisms, so that they give themselves more time to carry out that repair. Because imagine if your genome gets shredded, all your DNA is broken into little pieces. If you try to, you know, copy your cells when that's going on, you're screwed. But if you take a little bit of extra time and you have really good mechanisms to stitch things back together, then after you do that, you can then replicate your cells and grow.
Wow. For those of you who want to follow my long-lost friend John Eisen online, his Twitter handle is phylogenomics. In fact, why don't you spell it, John?
Yeah, Phylo genomics, Genomics. And unfortunately, I think I invented that word when I was in graduate school, and it stuck with me, even though now I spend time writing about why new omics words like that one are kind of lame.
So is it a word that people in your line of work actually use now? Like, can you say you've affected the professional language of your profession?
People do use it, but sadly not in the way I had originally used it. So I'm still cornering the space. My blog is phylogenomics, Blogspot, and my Twitter handle is this, and everything else, even though people use the term differently than I originally used it.
Well, we do live in a kind of Humpty Dumpty world right now where words mean whatever people say they mean. So don't sweat it. It's not just you. I'm just looking at your blog actually, and I just have to ask you about this from a couple of weeks ago. Pumpkin carving as a model for genome assembly. Now talk about the ultimate combination of nerds and fun. What is going on here?
So in my building, we have a symposium every year on Halloween, and as part of the symposium, the office here buys a bunch of pumpkins and gives them to the different labs in the building to have a pumpkin carving contest. And the night before, it turns out, or the afternoon before, nobody in my lab had yet done anything with a pumpkin. And normally I don't have anything to do with this because I'm just too busy and doing other things, but I just decided...
Because you're too important to be involved with.
Yeah, that's right. I'm too important to do lowly pumpkin carving. But I just decided, okay, I want to do something, and I came up with this idea of using pumpkin carving to teach about what we do in this building. So what we do a lot of is taking different organisms, isolating the DNA from those organisms, and then using, various machines that we have to read the DNA sequence of those organisms. And the way we do it, we have to read those pieces, really small pieces, and then try and stitch them back together into what the organism's whole genome is. So I cut up pumpkins in different ways and showed, basically that if you cut up the pumpkins into really big pieces, it's really easy to reassemble the pumpkin afterwards. And if you cut up the pumpkin into small pieces, it's hard to assemble the pumpkin back afterwards.
I'm looking through the pictures of the cut-up pumpkin. I'm gonna share it again on Twitter, and I'll post it on my blog after I'm done. But that's just unbelievable. All right, let's go back to the main topic of the day. One thing I want to follow up with you on the few minutes we have left. And for those of you just joining, my special guest is Dr. Jonathan Eisen. John and I were friends in high school and haven't talked to each other probably since the late 1980s. It's pretty nuts. But the clean room thing is really interesting because they're supposed to be clean, and you would think, probably most of us did think that they were clean, is the fact that, that you're telling us now that they are not, in fact, all that clean. Is that actually new information to the people who were actually working in clean rooms? Did they think the rooms were clean?
So no, they did not. So it turns out NASA and other places have known about this for a long time, and that's how we got involved, is that they've actually been maintaining a collection over years, like 30, 40 years, of microbes that they've been able to grow in the rooms that are, in theory, very, very clean. So they've known for a very long time that some organisms survive. Now, if you go and look in these rooms, they're remarkably clean. They are... there's no dust particles you can find. There's very, very little detectable material. But, of course, microbes are small, and it's really, really, really hard to remove all of the microbes from a facility, and it's really hard to keep all microbes out of any facility. And that's the challenge here, is that they're, building space vehicles in a big, giant room. They try to keep everything out of it, but sometimes things get in. And what's interesting is they also try to kill anything that would get into that space. So they have all sorts of filters and sterilization methods, And what's interesting is some things still survive. And that's where I'm interested in this, because I want to know, like, what is the mechanism by which these organisms have been able to survive these, very harsh conditions. And also, NASA wants to know, okay, what's in this room, because it's going to be on our space vehicle, too, on the outside. And we got to be careful when we land something on Mars or some other place that we don't contaminate that place.
So I've got about 1 minute left. When you find the microbes that do grow in places that are supposed to be clean, are you finding that they are the generic type of whatever that particular microbe is, or does it tend to be a mutant form of a particular microbe that happened to get in? You understand my question?
Yeah, I understand your question. I don't think we know that yet. My guess is that they're going to be generic forms that are found everywhere, but then get selected basically in that environment and everything else gets killed. But I don't actually know the answer to that.
Wow. It's fascinating stuff. Well, John, it's been just great to talk to you again after probably 30 years or something since the last time you and I talked. But
it's been awesome.
Congratulations on your success and having kids and all that. And we should definitely do this again. And say hi to Mike for me.
I will. Say hi to your family.
All right. Thanks, John.
All right.
Bye. How about that? That guy literally. So this is a funny. I think I mentioned this the other day. And I remember hearing about this. You ever hear about the one-man show called Defending the Caveman? Have you heard about that show? Shannon, it's just a great show. One of the things he talks about is guys can sort of not talk to another guy who's a friend for years and years, and then get together and say, oh, yeah, we're old friends, and just sit down, watch a football game, talk about whatever. And it's funny, I haven't talked to him in 30 years, but I guess I'd call him probably my second oldest friend who I still know, him and his brother Mike. It's kind of crazy. And I haven't talked to him since the 1980s. And there he is, a professor at UC Davis with a beard and kids. What a world we live in. All right, I have no idea what we're going to do. I do know what we're going to come back. More science.
This report is sponsored by the Broadmoor.
Looking at a couple of slowdowns getting through the metro area, southbound side of I-25 between the Downing Street Bridge getting over toward Yale. And it's also going to be busy on 270 eastbound starting at I-76 past York, the westbound side of 270. It is slow and go between Quebec and Vasquez. And it's also pretty crowded across 70 eastbound starting at Pecos getting out toward Brighton. Denver weather, clouds and sunshine with a high getting up towards 62. Also cloudy tonight, a low down to 49. Tomorrow expect an evening shower and 65. Right now with partly sunny skies, it's 54. With your traffic and weather, I'm Karen Johnson, 630 KHOW.
A glass of wine by the fire, a lakeside walk under the stars. The